Let's talk about how web apps are developed. What are web apps? Uh, Web apps can be very easily confused with websites, but there's a major difference between web apps and websites. Websites are typically considered to be static, while web apps are dynamic in nature. Gmail is a web app. Google Map on the website is a web app because it behaves pretty much like an application instead of a traditional website. Right? It updates the information much more dynamically. It has a lot more interactions, and it's just not a bunch of static pages linked together, right? So let's understand web apps versus native mobile apps versus hybrid apps a little better. So how do you discover them? So native mobile apps can be downloaded through app stores. Hybrid apps can be downloaded through app stores. Native mobile apps are really fast, assuming that all of them have been coded in roughly the same manner. Web apps are comparatively slower, and hybrid apps run similar to native apps. On web browsers, speed is dependent on the browser speed itself, so that gets constrained by that. Uh, how fast they are or how slow they are, that depends on whether the hardware acceleration is available or not. Okay, if it's a web app, obviously it is running on a browser, so the faster the browser, the faster a web application is going to run. Similarly, when it's native mobile app, if it's a fast device, if it's a good device, it will run faster, while if it's a slow device or not a very well designed device with low RAM or low CPU or low storage, obviously it's going to run slow. So it is dependent on the situation, but in general, if all other factors remain the same, then native mobile apps would be the fastest and most reliable. Hybrid apps would come in the second, and web apps would be the third. Native mobile apps are designed for and developed for specific devices. Okay, for iOS, for example, Objective C and now Swift, and Android, Java. While web apps are simply designed for the browser. Okay, because they live in browser. And Chrome, Firefox are the one of the two are the two most popular, most used browsers. So you can create a web app using HTML5 or JavaScript. And hybrid apps are compatible across multiple web browsers, as well as they can be installed on mobile phones. Native mobile apps, because they are native to the device itself, they can access hardware, the internal hardware of the device, like camera, GPS, and anything else. While the web apps do not require the access, and typically they do not also get access to the web app, to the hardware devices. Nowadays, with Chrome and Firefox, they are trying to give you access to camera and mic, but it is not as simple or straightforward as native mobile apps, right? And same goes for hybrid apps. Native mobile apps will cost you the most. They typically require a lot of budget. Web apps are cheaper, and hybrid apps are somewhere in the middle. So, just to jog your memory once again, what are hybrid apps? Hybrid apps are essentially apps which do not use native languages like Java, Objective C, etc., to build native apps. They are coded using the traditional languages like LAMP. Like, so you'll be having a PHP backend, you'll be having Angular in the front end, and stuff like that. And you will use some SDK. You'll use some SDK. For the moment, you can just take it as vague as I'm telling you, that there is some SDK available which can convert that code, convert the regular website's code into a hybrid app. Okay, it adds the libraries, it adds everything else needed, and it creates a hybrid app out of it. So web apps is a program that runs on a computer with a web server, right? So a web application would be like a mint.com, okay, or Google Maps, for example, or Gmail, for example, while a website is like a CNN or anything which has a lot of which is essentially a CMS driven thing. Okay, so this is interactive in the browser itself, as compared to CNN, which is not, which is interactive in the sense it is essentially linking across the site with via links. while a web app will have a lot of dynamic content. Almost the entire app will be about dynamic content, right? So Gmail is a prime example. So what are the components of a web application? It will have a administration tool, it will have client side, it will have a recommender server, or it will have a generator server. Okay, let me just take you through this. So client layer is simple. It's simply the client side, that is you, me, anybody else who is using the application on their phone or their laptops or desktops. Okay, this client application layer is going to interact with the web service API, which is essentially sending you, for example, if it's Gmail, it is this web service API sending all the emails that you are receiving. Okay, it is responsible for so every time a new email comes in, this web service API layer is responsible for interacting with the client application layer and sending the fresh emails to the client servers, to the client side. This web service API interacts with the so for example, if it's a uh, uh, e-commerce site, for example, so the application layer would contain an online recommender service, or even, for example, in a Gmail, there are certain emails which go in the primary inbox. There are certain emails which go in the updates or promotion tabs. So the online recommender services would be responsible for essentially generating recommendations that what should go where. Okay, and this will send the data to the API layer, which will then send the data to the client application layer. Okay, this web service layer with can interact with action service. So for example, if you have asked to delete you have decided to delete a certain email, or you have bookmarked an email, or you have starred an email, then this information is again passed to the web service API, which then interacts with the action service, and this information is sent to the database, which just contains the actions. Okay, and this interacts with the action based generators, which is data mining layer. Okay, it will use the all the data that exists to create the actions that are um, you know uh, that are expected or anticipated for the user. Okay, and similarly there are content based generators, which is if somebody does XYZ, then these generators work. If there are new type of content that comes in, then this generator comes in, right? And this works with the database, with another database, which sends the information to offline recommender services, which goes to web service API, and then finally to the client. Okay, and this recommender server also has an administration layer, which includes a management layer, an API documentation, and the actual administration interface where you can interact with the interface. This is one form of web application, depending on what web application you're talking about. For example, Google Maps uh, infrastructure, the entire schematic will be very different than this one, for instance. Okay. A typical web application has two components similar to a website. It will have a client side, which has essentially, it's just a graphical representation of the functionality of the web app. This is the side, the client side is where the user interacts with the application. It is typically developed in HTML, JavaScript, and CSS. You can obviously use frameworks like Angular or React or whatever, and there's no specific OS or device related adjustment. There might be some minor tweaks depending on the browser version or the OS version, but that is not at the level of a native device. While the server side consists of app logic and database. Okay, it just like in the website scenario, it is written in PHP, Python, Java, what have you. Okay, so what are the different models for designing these web apps? So model one is where you have one web server with database. Simplest model, single database is part of the web server. Now there's only one web server which does everything. It stores the data, it serves the data, it processes the application logic. It has everything in one base. So it is good for private projects or for testing. It is not good for production, because if something goes wrong and this server goes down, then everything goes down. While model 2 has two or more web servers with one database. Okay, the web server does not store any data. So web server is responsible for purely serving the data and for getting the requests and processing it, while the database is on another server. And the idea here is that the web server will process the request and will write the data to the database, read the data from the database, and that's it. Okay, and this is known as stateless architecture. Okay, the server forgets about the transaction. It just takes a request, does the processing, stores the data in database, reads the data from the database, sends it back, and forgets about it. And this is known as stateless architecture. Remember this term, stateless architecture. This will be used a lot of times. So now, even if one web server fails, there's another server to support it. Okay. Now the risk lies with the server on which the database resides, and if it crashes, essentially the entire app completely goes off, right? And that is why you will build redundancy in your entire architecture itself. You will build multiple web servers, you will build multiple database servers, and then you will create complicated systems so that you can track or you can sync the database between different servers. You might also create, there are multiple architectures available for database management as well. So there's a master slave version in which there's going to be a master database and there's going to be a slave, and master and slave will keep syncing data between each other. Okay. uh, and similarly on the web server side, web server also has something called you know an automatic spawning of servers as and when required. So AWS has created this entire new category of new class of infrastructure, which scales up or scales down depending on the requirement or the amount of requests that the system is getting. So if there are a lot of people visiting the site, then obviously more web server, more infrastructure is needed. So it will automatically create or launch new web servers, okay, to handle the new fresh load. That's how it works. Okay. And this is the third model I was talking about. So which has two or more web servers with two or more databases. The databases are divided in the following manner. So it can be, the databases can have identical data, or data is evenly distributed in two databases. Okay. Now, if one database goes down, the request will automatically forward to the other database. So there are multiple models that exist. Like I said, master slave. There's another model in which a benzene ring kind of a structure is created. I think the project name is called Apache Cassandra. It's a very interesting model where the data is consistently stored and maintained in a benzene ring kind of a structure. Um, with each node working as a database, and now the data, it kind of heals itself. The databases kind of heal themselves. If something goes wrong with one of these nodes, the rest of the databases will send the data back as soon as the node is up and running. Will send the data back and database back, and everybody will maintain the data in one place. Okay. um, right? So a legacy web app would have a simple client and will have a web server, which will have a web construction logic and a business logic. HTML data is requested, HTML data is sent back, and this goes on and on. Then there is a widget web app. What is a widget? Widget basically means, as against to this one, where the entire thing refreshes, the entire page refreshes. A widget is essentially a small section of the page that refreshes. So for example, you must have seen in news sites or a lot of other sites where there's a weather app, right? There's a weather widget, or there's some small widget or score widget, which is a cricketing score widget or some games sports widget, which will update the score automatically. So just that section, that block, is actually a widget web app. Okay. So that widget is using Ajax and JSON to interact with the web services or the web server in the backend, which is then sending the HTML back to the widget, and the data is updated. Then there is a single page web app. The best example would be Gmail. So everything that you see in a Gmail interface is essentially powered. It's completely fresh. It's not static. It uses JSON AJAX to essentially interact with web servers and get the data back. So to conclude, web apps have completely transformed, starting with Gmail especially, and Gmail is credited for most of the advent of web apps. So web apps have completely changed the landscape of web applications or websites. Now almost all the websites by default are dynamic in nature, and they interact with web servers consistently to get the latest and the greatest data. Okay, and that is how all the recommendations, everything has started coming in very easily. And nowadays, in fact, it's very hard to imagine a site without 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 the usage of any kind of web application or dynamic content. Okay, and if you're building any kind of website, unless it's a very static information site, expect that you'll be dealing with a web application. That's it for now. Thank you.